Hi, my name is Dalibor. I run a small business manufacturing Nixie tubes, and currently we are working on a new Nixie tube model that will be called F. And the main task for the F Nixie tube will be to find a way how to produce it more efficiently, keep quality and improve the price. So, in the past 2 weeks we did a lot of work, but sadly not much on the F-tube project, but still we made some progress. First thing that I want to show you is that we got the pins for the glass to metal seals for the stems, which is the most important part that we don't have right now. And I was trying two ways to get the pins. First of them was to order a sample of the alloy, of the sealing alloy, and try to cut them ourselves. The alloy is still on the way. And the second way was to find a supplier that would deliver the pins finished. So the second way of a supplier who is already tooled up was successful. We found a company that is called Formcut. They are based in New Jersey in the United States, and they also supply pins for glass to metal sealing industry. Which is important because they already know the specific demands on the surface, let's say on the quality of the alloy, that there should not be any cracks in it and so on. So that's good. The pins look perfect, they are smooth, they are uniform, the ends are, there is nothing I could object. So there still can be some surprises, but from what I see now, I think the pins will be absolutely perfect. In the next 2 weeks I want to do another attempt to make stems. From the previous weeks we have already the mold holder that will be synchronized well and will work, and the last remaining part of this tool is the pair of the molds of the dies that will press the glass. Initially I plan to make them out of brass, and later, after discussion with friend, I'm thinking of making them from cast iron. Cast iron should not stick to it because it contains graphite, so it should be easier to work with it. So the cast iron arrived, we have the bars, and this week we are going to turn the basic shape out of them and prepare it for the CNC cutting of the holes and other shapes. So far we were focusing just on the stems because this is the most problematic and most critical part of the Nixie tube. It's also the part that we don't have, that we cannot make, we don't have a supplier for it. There are many more tasks to do, many more manufacturing steps, so let's look at the slightly bigger picture. So this is the workflow that will turn the raw material and parts purchased from manufacturers into a finished product, F Nixie tube. The final goal is to run a production of roughly 20,000 tubes per year. This is quite ambitious task, and at the beginning we'll definitely want to produce just prototypes and then a small series runs. And for this low-scale production I marked green the fields that we have at the moment from the manufacturer of the R tube. So as you can see, the part that is missing is here, it's stem forming. So we are able to prepare the glass tubing, the glass rings, everything, even in small volume, but that's enough for the prototyping. What we are not able to do at the moment is forming of the stem. After the stem is formed, we will need to anneal it, and then because it will be oxidized from the flame, we will need to etch it. So this is also something that I don't know yet, I didn't try, so it's not marked green. The finished stem is here, and it comes into the assembly of the internal system. So you can see digits, anode mesh, these are the stainless steel parts that we have, and we have suppliers for them, we know how to clean them. We'll just need to scale these procedures that leads to the assembly. And here you can see anode cage part, which is also not marked green. Here we will not use stainless steel as we do for the R tube. I want to use an ERA correct material which was used in the old Nixie tubes. It's this gray metal which I think looks very nice, but it's difficult to get in low volumes. More on this topic later. So after the internal system is welded, we have all the spot welders that we need for the small scale production. We will get finished internal system. This internal system will be put together with envelope. We are also able to make the envelope ourselves in small volume from raw tubing. Once the internal system is in the envelope, we will seal it, we'll pump it, and the filled tube with gas is put on a burning machine, and the burn-in tube is put onto inspection and cleaning, and we receive the final tube. So you can see that we are quite close to the prototype. One part is missing. This is the stem forming machine. This is where I spent most time in development of the F-tube. But it's not the only part which is under development. There is another project under development where I am just an observer. The two young promising engineers who work for us part-time, Radim and Lukáš, they study electronics engineering on university. Radim is finishing his master's degree this year, Lukáš is finishing his bachelor's degree this year, and they came and asked if they can make some project for the F-tube that would lead to their diploma thesis and the bachelor's thesis. And so we discussed what we can do, and the conclusion was that the best thing will be to do the burn-in machine, because it's quite a complicated machine, it's a lot of work, and it's also the last inspection step, which is very important because it makes sure that only the electrically good tubes goes to the customers. The current burn-in station that we have was developed 5 years ago by Sebastian from Germany. He came to work for us for 1.5 years, and this machine was developed during that time. And over the years, the machine caught many tubes that were marked as potentially bad. The machine is able to measure small differences in electrical parameters between the tubes, and those that differs from the mainstream, from the most common tubes, are marked and they are later rejected. So this machine that we already have, that was developed by Sebastian, help us to bring the reliability of the tubes much higher. The task for the new machine that is developed by Radim and Lukáš will be to speed up the process, automate it, and also improve the reliability of the electronics, because the version that Sebastian built was like a first version, and sometimes it can fail, sometimes it lose some settings in the memory and so on. So this is also something that we want to improve the reliability so that it is rock solid. So this is the model of the burn-in machine that is developed by Radim and Lukáš. I'm just checking from time to time, opening the model just to see what new ideas it involves. So what's the purpose of this machine? It will receive freshly filled tubes. The Nixie tube after filling doesn't perform as it should. It's not able to glow, and this machine will run it at higher current, and after some period of time of operation at higher current, the Nixie tube receives its final operating current and operating voltage parameters. At the end of the process, the machine also measures the parameters and is able to tell what Nixie tube is good and what is bad. At the beginning, you will have here boxes with the fresh tubes. The robotic arm will take one by one and put them here onto these sockets. Every Nixie tube will go through this process on an adapter board. This adapter board will help to position the Nixie tube precisely so that the robotic arm knows where to expect it. So the arm will take the Nixie tube, it will position it here in the socket. When the sockets are populated with the Nixie tubes. These air cylinders that are hidden under the table here will pull this mechanism that will lock with these tabs. It will lock the boards. So the electrical connection between the tube itself and the electronics will be done through the adapter and through these pins. These are pogo pins, spring-loaded pins. Once the burn-in process is finished, the robotic arm will take the tubes one by one and it will position them here on this socket. At this position we have a Raspberry Pi with camera, so here will be done optical inspection. We will need to read the serial number from back of the tube, and all the measured electrical parameters will be paired to this particular tube. Once the Nixie tube is measured, the optical inspection is done, it will be moved into these boxes. These two boxes will be for the good tubes and one box will be for bad tubes, the tubes that were marked by the software as tubes that differs from the common electrical parameters. The motivation to make this project is not just to develop this new machine, but also to learn how to work with robotic arms and also get more information about optical inspection. This is the stuff that we would like to use in the future in more machines to be more efficient, because like doing things like this by hand costs a lot of time, a lot of money, and also it's not super exciting thing to do, but it must be done. So we need to search for ways to do things more efficiently. So thank you for watching, and I hope that in 2 weeks I will be able to show you some progress on the glass stems.